like Sean said, I'll be delivering a short presentation about managing light rail London Trams. That's it. Now, but before I start the presentation, I must say, must discuss Transport for London's vision and values. The vision is to have a green heartbeat, strong green heartbeat for London, and we encompass that with our values of being caring, open, and adaptable at everything we do. We have a vision to be more economically friendly and support our customers in the wider city. By 2050, we want to reach some net zero targets, so we're all driven to that desire as engineers. Introductions about myself. This is the first time I'm giving a talk to PWI, and so many of you may not know who I am. This is a picture of me. If you're wondering, handsome young me. On my apprenticeship days, I'm a permanent way engineer at Transport for London, currently assigned to London Trams as a track asset engineer, and I've been here for about 3 years in November. Yeah, enjoying it. My background, I started as an apprentice for Network Rail, so I did the whole Portsmouth for a year and then assigned at London Bridge DU for 2 years. When I left the apprenticeship scheme, I came out as a STO, so I did a lot of platform gauging, sideware, all of that technical stuff with dumpy levels, theodolites. Had an opportunity to become a section supervisor and secondment at the same DU at London Bridge. So I did that for 2.5 years. That was a 24/7, 365 type of job. Never slept, did all the weekends and the Sundays. Really enjoyed it. And then following that, I went over to Saudi Arabia. I did some consulting for Network Rail Consulting. I did that for 2.5 years. Met some fantastic people. Some of them were PWI members and associates. Again, pretty similar stuff in terms of track maintenance, doing the engineering management side of things as a consultant. I got bored of that, and I did a bit of work in control in Basingstoke in the Rock for Network Rail. I would have stayed in that job, but it was just too far from home, I think. That burnt me out. So I went back to something more suitable, familiar. I was an assistant track maintenance engineer for Clapham Junction before taking this role as a track asset engineer, doing something completely new, light rail. I had done pretty much everything else in rail, and I thought this was a fantastic opportunity. So that's a bit about myself, my experience. And so we begin. London Trams, managing light rail. So the overview of the presentation is I'm going to talk a bit about the infrastructure of the track, some of the permanent way assets, some of the unique features that we have here, some of the challenges that we have at London Trams, a bit about railway, which is one of our biggest challenges at the moment, maintenance, some of the future plans for trams, a little bit of a case study around Shirley Hills Road crossing. I can't get too detailed into that one because that would require a whole presentation by itself. And then I'm going to wrap it up with some Q&A afterwards and round it out. So, history of trams. Well, if we go back 200 years now, there's always been some sort of tram system in London, and in some way, shape or form, in various degrees, we whittled it down to what we have left in Croydon. They were at one point all over the streets of London trams, whether they were trolley buses or they were on rails. But the most important date for us in Croydon is pretty much in 1994, when the approval was granted to run a tram network at Croydon. 2000, the services started running. Croydon Tramlink started operating services. So this makes this our 25th year anniversary. Just had our anniversary party on May 10th. In 2008, it came under the control of TfL, who are now the owners of the infrastructure, including the fleet, and the operation is provided by First Group. And like I said, 25 years we're celebrating of service in London. London Trams, where is it? Southeast London. It connects East Croydon to Wimbledon, out to Beckenham and Elmwood End, and down to New Addington. It's about 28 kilometres of track, but in total 49 at each rail. Almost 40 tram stops, It's 750-volt DC, so that's the one that sticks and kills. We have a maintenance depot in Therapia Lane and a fleet of 34 different trams. Services run between 7.5 to 10 minutes, although on some days it can get longer. Not my fault. Maximum speed of 70 kph on the line, and we have a nominal track range of 1435. A unique thing about London Trams as well, we're an isolated network. I think at one point, some of the drawings I've seen, we were connected to the main line at Wimbledon, but that no longer exists. And so that gives us some difficulty in getting machines and stuff on the track. And it's completely step-free, something that we're proud of as well, to allow all customers from all different types of physical capabilities to access our trams. We've got low loading floors, and we maintain a good platform clearance for all customers. Talk a bit about track forms, embedded track, concrete slab, the little of it we do have. So when it comes to embedded track, we have what we call the on-street sections. So this is where part of the track is shared with the highway users, road users, and pedestrians. As you can see, it's an open environment. Anyone can access it, do what they like. And believe me, we get some scary stories from time to time, but it's the nature of the business that we're in and the environment. That's the whole purpose of Trams. It connects little towns, cities, takes people to hospitals and closer to the destination, essentially. So we have on-street track. We also have segregated track where we don't have the highway entering. So this is kind of a different environment, but we still have pedestrians, as you can see in the photo, wandering, doing what they like, dropping bits of debris, people's vapes in the grooves, and all kinds of stuff. Chicken bones, we've had earphones, fidget spinners, nuts, bolts. Yeah. This is the environment that we have to work with. We have a very, very, very small section of concrete slab track. I have to give this some mention. This is at Wimbledon. The purpose of this slab was to raise the track bed to the platform height to get into Wimbledon Station, because the platform to the right is for National Rail, and they've got 750 and 930 platforms there. R1's slightly more shallower. So yeah, that's a small mention of slab track. Road crossings is another track form that we have. It's slightly different to the embedded in terms of the material that we use to construct it. The slab is quite slightly different. And yeah, so this one is constructed with a flat plate against the flat bottom rail. I'll say a bit about that. It's not a level crossing, although I tend to say that from time to time. It's a road crossing. It's controlled by traffic signals. Cars stop at red, they go up green. It's as simple as that. It's a line of sight type of network, so relies heavily on drivers' visibility and them acting and protecting the customers as they see fit. We have ballasted track, and again, another misconception is that we have little ballasted track, but in fact, 80% of the network is ballasted track, featuring a mixture of different components, and it's conventional, just like National Rail. We've got wood composites, both different types of bearers, angular granite ballast, so nothing that you're too similar to what you have on your networks. I'm going to talk about some tramway features, some of the stuff that makes the tramways quite unique. Interlaced track, which is this is in between Bedington Lane and Mitcham, where we have a single line occupying the two tracks and one envelope, essentially. I think this was done purely to prolong the life of the single line section, essentially. So what we have at either end of that interlaced track is two crossings. That was for one tram to go and travel on one rail, one tram to travel on another rail. We're going to be replacing this asset in October. So we are keeping the interlace, but we're making the crossing a little bit wider to allow for maintenance. We're changing it from a 1 in 7 to a 1 in 8 crossing, widen the gap between the two rails so we can get things like welding apparatus on there or fish plates if we need to clamp. We have interlaced track points. So basically, where we have perpendicular running into our track, we don't want to put points for obvious reasons. We get debris in the points, we get damage to the switch blade, which is free moving and hanging. So what they do is they extend the intermediate section so to allow cars to traverse over the full rail because it's just better structurally at that point. So this is at Church Street. If you ever go down there, if you're in Croydon, that's the interlaced track. So we have more than one of these points, actually. I think we've got 4 in total, interlaced points. We have very tight radius curves. We've got many of these in the town centre in particular, 25-metre radius curves. These are laid, some of them with adverse cant, because we've got to follow the camber of the road. So we experience very high rates of wear here. There's pretty much nothing we can do here. This is inherent. We have to live with it and adapt our maintenance regimes to suit the aggressive wear that we get in this pattern. The trams navigate these curves quite well. Actually, they can navigate curves up to 18-metre radius curves. They've got very small wheels. They've got independent bogies. And so it's nothing for them to traverse these curves. In the ballasted section, we have up to 30-metre radius, so not so bad. We've got some incredible gradients too. So this is the top of Crown Hill in East Croydon, where it's a 9% gradient. Probably wouldn't find this on the main line somewhere. Into the town centre. Again, trams find it very easy as a light rail vehicle to get up and down these hills with no issue whatsoever. Another high point is at Gravel Hill for 8%. We've had issues of runaway vehicles on Gravel Hill before in the past, so we've put some procedures in place to prevent that from happening. But essentially, yeah, we have some incredible gradients there. Just talk about that adverse cant in the highway section. Now, my diagram is what I drew a couple of days ago before, very exaggerated claim, but you can imagine the curving round to your right on a road. You've got to follow that camber and that and that road surface. And so we have to design in adverse cant. And often when we get designers who come in from third party to design our railway, they want to apply traditional railway principles and they can't make sense of it. And we have to describe to them why it is what we do. And this is the diagram that I use. Very simple, I hope everyone can understand. So that's some of the challenges that it presents to us, particularly on Lebanon Road. If you go down there, some of the curves, adverse cant. We have a different wheel profile. So the wheels are designed for flange running, but we don't have that on the London Tram network, so we don't run on our flanges. But they are designed for that. These are tram wheels. They have a little bit of a longer flange to navigate some of those curves. And it's slightly different to the wheel profiles that you get sort of a P8 or a P10 on mainline or underground. We have a back-to-back gauge, which is incredibly tight. So we require vehicles to be at least 1380 back-to-back. That's slightly narrower on the main line because we've got flange rays of 29 mil. So if you go on the main line, your flange rays are 50 mil clearance. This is a huge problem for us for getting RRVs and machines onto track. We have to often take off the check rail or adapt the machine, which incurs quite a lot of cost on us. Also, our check rails sit 21.5 mil above the running rail when it's new. That also presents challenges for RRVs that have road wheels. They often come into contact and strike the check rail. So it's one of the things and challenges that we have to deal with. A bit about components and our configuration, really. Grooved rail, I'm sure many of you are aware of it, but our profiles that we predominantly use is RY59, although we have some 54 elements or some 60 elements in the network. Essentially, this rail was designed to be laid flat because it's inclination is built into the head of the rail. So you wouldn't put it on a sleeper with an incline of 1 in 20. Most of the rail is at grade 350. What we're starting to do now in some of our curves, 25-meter radius, is increase that steel quality to 400 GHT, something that the Europeans have been doing. So we've been following suit to do that. So in particular, Barclays curve and at Reeves Corner, we've got 400 GHT through our curves. And they're also through our S&C elements. So the stock rails of the embedded points will have 400 steel built into it. This is a typical track bed construction for embedded track. So everything has a slab. It's laid in a nice concrete slab, and the rail sits in a concrete channel, to put it quite simply. Within that channel, then we backfill it with a polymer, keep that lateral stability. The rail is gauged to 1435, and over the top of that, then we put a wearing course for tarmac. This is how embedded track is laid to allow for the highway. We allowed a 6 mil tolerance between top of the rail and the wearing course of the road, which is often isn't kept because it's difficult to do that. But in any case, this is what we have. For the road crossings, typically, which we're trying to design out, actually we are actually designing out of life now, this design of a flat bottom rail with a bolted keeper. So this flat plate that's bolted to the flat bottom rail. What made the issues here, which I'll talk about later, but essentially, as the road wears away and potholes are formed, we get loading onto the flat plate here, which then in turn breaks the bolts, or snaps the plate, and obstructions affect the flangeway between the rail and the keep. We have this design in many of the road crossings, which we are phasing out through our renewals program. Flat bottom rail, traditional, so it's a lot smaller than your 110 pound or your 1060s. We incline it at 1 in 20. It's a smaller, lighter rail. So if you're buying in bulk, if you're buying 30 tons at minimum, it's far cheaper to buy 30 tons of S49 than it would be to buy sort of 113 pound. The whole point of tramways is to keep it cheap, keep the cost down, and so that's what buys in communities really across the world into tramway systems. So we use components to suit that. There's talk of changing this and going to 113, but I'm not quite there yet. I think there's still some benefit to using this, but because markets that make these components are overseas, and with our issues with Brexit, it's quite difficult to source these. They have very long lead times. However, we are where we are. This is S49 rail. It's got a smaller foot as well, 125. Sleepers. So predominantly, we have concrete sleepers throughout the network. We inherited a tarmac T16 sleeper from the constructors of the original tramway system. And we're slowly trying to phase that out to put in, where we can, T-cup composite sleepers. We had some issues last year in Sandilands where we had some temperature variance with the gauge. So as the temperature heated up, we had the track gauge spreading. It wasn't much of an issue, it just wasn't in installation tolerance, but we're going to continue to use and adopt this so we can meet TfL's green strategy. And we find it to be a better sleeper than woods and easier to install than concrete. Where we do have to install concrete, we are installing the 1502 designed by London Underground, and that comes with fast clips, which is a type of fastening that we're trying to move over to rather than the SKO, the screw, simply because it's easier to use, it's better. We do have wood bearers through our S&C layouts, pretty much most of them on the ballasted section, and we've got some long bearers as well within the platform to keep that alignment. It's one of the techniques that we use. Fastenings again, so we're trying to move away from this where we can, move into a fast clip solution. It's nice and easier to use and easier to manage. When you take these screws out and if debris gets in the hole and you over tighten it, you crack the sleeper. And We just find that the fast clip is better. But yeah, it's high toe load all the same. S&C. So point mechanisms. Now, I'll be honest with you. It's not my area of expertise. I've inherited this as an asset. I've never had to do it before, but I'm learning slowly. I've got a training course later on this year to attend. All of them are owned by, well, all of them are manufactured by Hannon and Carl, and they sit in the ground in a thing called an earth case. So it's in the track bed. It's maintained by the permanent way team, and it's basically got a motor in there, a couple of springs and levers that switches to whatever position. There's different variants as well, because we have motorized, hand swung, throw over types of point systems, but they pretty much all do this. Sprung points, again, another type of unique feature, I would say, to the tramway. It's a cheap, cost-effective way to have a set of points that allows you to operate it through different routes. So essentially, sprung points are designed to be pushed through. So we get flange back contact on our points. Some people might find that scary, but this is how these points are designed to be used. Essentially, they return to normal once you push through them. It requires no inspection after that. And to aid in that movement of the switch, we install something called Roll, which is a dampening device that prevents the switch rail from slamming into the stock and damaging the componentry right there. So that diagram at the top, I'm just showing you what would normally typically happen if you had a loop. You know, tram goes round, the switch is always in a closed position, allowing to diverge the route, and as you come through, it will push through. It's just a cheap, simple solution, so we don't have to motorize the points. Ballasted track points. So this is a picture of Sandilands at the handback as I was taking over, so it's a good day for us. We've got a number of different radius turnouts, but they're all small, everything less than 100 meters. We've got varying different crossing angles, from 1 in 8 to 1 in 2 in the depot. They're all manufactured by VAE, and so they have a unique design around the switch tip, where it has cover underneath the head of the rail, so it's slightly undercut. But they're all shallow depth switches designed for facing and trailing moves for a maximum speed of 25 kph. We've got about 61 sets of these points on our network, so a good fair amount with varying different common and obtuse layout crossings. I just want to go back as well. Where you see that picture there, the glued ballast there, that isn't necessarily to hold the track, the forces in the track. That's to prevent the ballast shoulders from falling away. Again, to remind you, it's an open network. People do walk down here, they kick ballast. That's one of the ways techniques we use to keep the ballast from being kicked away. Yeah, so S49 shallow depth switches. Again, our lead lengths are really short. This is a 7.8, 7 meters, 800. And we have something called an anti-creep device installed into our switches. So what is that? Basically 2 pins on a base plate, preventing the longitudinal movement. So in the foot of the rail, we drill 2 holes, put the stock rail down, put the first or the last clip secured on the switch, and that prevents that longitudinal movement. So that's how we manage stress in that area. Essentially, these are unstrengthened sets of switches. Embedded, again, works very similar to the ballasted. We have an earth case, an inspection cabinet, go in there. Same with the motorized, although they're slightly larger, between 50 and 100 meter radius turnouts. The elements of it is 400, so the stock rails are 400, the switch is 350 to allow us to do some weld repairs in those locations. Again, it's a mixture of trailing and facing, and we've got about 15 sets of these. The crossing block is made out of one solid block of steel. So when I went over to Germany, they had a massive block of steel. So it's not hollow as sort of ballasted crossings are. They just machine it, and that prevents it from snapping and breaking. You don't have crossings breaking. So it weighs about a ton. But this is what it looks like. So the switch rail itself, probably about 80 mil in depth. It sits on a plate, a flat plate, slides along that plate. They call it a monoblock switch, and I'll show you in the next picture because it's basically they weld this block onto a bit of rail, and you've got in your head like a picture of a swing nose crossing. It pretty much works like that. It's all shallow depth all the way through until it's welded at the other end. The switch rail is represented in blue here, and there's 4 bolts at the back where the switch is attached, so we can remove it for any repairs and maintenance. So the welders would get in and weld, pretty much, yeah. And that's the block. And the grey section is the actual block welded together with bits of steel to form this one S&C unit. Lubrication on the network, so we do have them. We just don't have them within the embedded sections because the grease takes the contaminants, and that's a whole nother story we can do, and a whole nother presentation on that. Essentially, we have lubrication in our ballasted section, friction modifiers. We're using the very old LB Foster GDUs. It works for us. We've looked at other stuff, other designs, newer designs in this century. It's probably not going to work for us because of the size of our rail. This works fine, and we're happy with it at the moment, and the grease that we're using as well. I had this gauge designed as well by LB Foster. Asked them to produce a gauge for us, do a study on our wheel profiles, rail profiles, because previously our teams were going out and adjusting this manually. So now we have a gauge, and hopefully that can help with the number of noise complaints we have on the network. CRT management, so it's not much different to anywhere else in the UK. Our SFT is 27 degrees, and we aim to achieve between 24 and 30. We're happy with that. There is some different nature to how we stress rails that are below 75 degrees radius. So we do stress all radius curves here. There's just a different procedure in how we go about carrying that. We have remote temperature monitoring as well. So that's always live on pretty much all of our network. So we're always keeping an eye on temperature. We also have expansion switches, adjustment switches around the network to allow for that thermal expansion. And we make good use of LRPs and glued ballast, particularly pretty much in every renewal, just to keep those alignments for us within the curve, especially in those tight radius curves. We do carry out a geometry inspection. So a team comes out to London Trams. They fit one of our trams with lasers, cameras, you name it, everything, laptops. The tram runs around the network, does all of the dynamic recording. It also points a laser at the rail so we can look at the rail profile, see how much of the rail is worn. Really good stuff, 4K quality videos. It also measures the overhead line and any passing structures and clearances as well. And we're working with the company Deutzer to look at how we are going to manage our representing our track quality index, so to speak, CCQ charts and stuff like that. So we've got further work with Deutzer, but the data that we get from them is phenomenal, to be honest with you. We also have rail inspection and testing, so this is done on an annual basis too. Ultrasonically, we do that with pedestrian testing. Someone goes out and measures the rail. For rail profile measurement, that's done through another machine, about, and that produces for us loads of mini profiles, which is helpful for annual planning. So, how is the asset managed at London Trams? This is a very simplified version, but essentially, we have an infrastructure manager at the top in the white, and he manages a team of maintainers, civils, systems, which is S&T, old money, overhead line, and a track manager. So he's like a section manager. Under the track manager, he's got 3 supervisors and he's got 6 technicians. That's all we have to manage 49 kilometers of track. So we have to have a lot of labor support us in some of our tasks. And we also have to contract out a lot of our inspections and maintenance work, third-party suppliers, essentially. Myself, I am to the right of this in the dark green as a track asset engineer. And simply, I report to the head of engineering. She also has a fleet of engineers herself on one side, on the infrastructure side. And I provide assurance to the head of engineering that the track manager has done his job, essentially. It's my job. With me, assisting me, I have a track engineer who is with me 2.5 days a week. And she works on long legacy items for us at Trams, things that need some time and a bit of attention to detail. And I've got a track project engineer who works on all the projects that we deliver. He's a technical assurance and technical lead for the project. The track manager, as you can see, comes over on the other side under the infrastructure manager, who all reports into the general manager of London Trams. Hierarchy of assurance. Again, this is a very simplified version of it. Track manager does all the maintenance. He provides assurance to me that the maintenance is complete, the track is safe to run, and I provide assurance to the head of engineering. That's pretty much how it works in a simplified way. Governance is pretty much similar to what everyone's used to. So the standards are the overarching document, and essentially the standards would say track gauge needs to be 1435. The procedures would tell you what the tolerances are, the limits of that, and the work instructions would dictate how you do it, essentially. So I am the custodian of all the standards for track, and yeah, typical governance procedure. And me and the track manager work on how the procedures is dictated and work instructions go out to the team. So my role as an asset engineer, just to simplify it, I provide assurance to the head of engineering that the assets are safe to continue using. Also the custodian of all the standards. I'm the lead track engineer for Trams, so all of the responsibility on track is for me, whether it's renewals, asset strategy, 25-year plan, 5-year plan, all of the technical assurance stuff, all of the derogations come to me, technical non-compliances, technical notices I issue, and I do that throughout the entire asset life cycle. I also contribute to the direction of the maintenance and asset renewal plans, along with asset strategy engineers and teams and asset managers in different parts of the business. And I take my resourcefulness and I grab from Sean sometimes, some DLR engineers, from LU, all of their experiences, trying to implement and change things. Trams is unique. It's a fluid environment. And again, it's a lovely place to work as an engineer because everything's innovative, everything's new all the time. We don't have to stick to a regimented system. I just wanted to touch on communicating with people literally across the world since I've had this job. So red is the countries I visited. Obviously, I visited England because I live in there. But I was in Germany last year twice and went to Austria on FAT visits and speaking to other engineers out there. I've had discussions with manufacturers in Australia and China, engineers in America, Canada, all over Europe. Light rail is becoming something that more cities want to implement because it's a greener, safer way to travel. So lots of countries are doing it. Even in the UAE, I've been speaking to some of the engineers out there and in Qatar, where they are spending lots of money on building these transport systems around their cities without having to spend so much money on tunnels and viaducts, bridges, etc. So some of the key challenges I'm going to go through at London Trams quickly. So I've got 8, but I'll go through them very quickly. Everyone has this. We've got an aging infrastructure. From when it was built, even before then, I've got 1950s rail in some of my sections. And so we need to invest in our infrastructure because it is aging, it's tiring. We don't have the modern maintenance techniques or asset management systems like Network Rail do. We don't have a Milton Keynes. A lot of our data is managed on Excel spreadsheets, and we get by, but we would really appreciate some modern software to manage that. The funding for the asset renewals isn't as big as everyone else's. It's not in the billions. It's not even in the millions sometimes. So we have to play the cards we get. Highway interface issues, as I've discussed here, stuff in the grooves, wheel damage is a big issue for us at the moment. Just even getting access to go out on track to change rail, difficult. You've got to liaise with the council, highways agency, get road blockage, put on buses, diversions, signs. It's not easy. It's not just about getting in there and changing the asset. It's planning to do. Track access for on-track plant. This is becoming a major issue for us because we haven't done tamping in a few years properly of the network. Shriyabao retired one of their light rail tampers, which has mean that we had to go out to market to look at other tampers and other options. And it's very difficult to get access for us on track. Train it in, and it's costly. We're an isolated network. We're not connected to anything on the main line, so challenges are even greater for us. Again, complex design elements of the geometry, the bespoke componentry and the availability, very difficult. Again, having to go out to Europe or even further to get some components to bring back in the UK and clearing through customs, very difficult. Specifically with BAE, we want to get a van over here to do our maintenance for embedded points. It's very difficult to get through customs with a van full of tools and gears. We had to cancel that. And lastly, limited supply of constructors out there. There's only one guy in the game for us in London. Unfortunately, I'm not going to mention their name, but the competition isn't there, which means that innovation isn't there. Same people doing the same jobs, making the same mistakes. We want a bit of competition in this market. And because we're in the southeast of England, all of the light rail systems in the UK are up north: Birmingham, Nottingham, Manchester, Edinburgh Trams. They're getting the best guys, the guys that live in those areas, and we're getting what we have, what's available. We have to compete in a sense. I do want to touch on railware, which is also a problem for us in embedded track. So in the town centre, we've experienced in the last couple of years several sites, high rates of wear. This is obviously due to the inherent design of the geometry. There's nothing I can do to change the alignment. We have to follow the highway alignments. But also, we haven't invested enough in our renewals or changed the strategy of doing one embedded track renewal a year, which was something that I've been trying to get the business to understand, that we need to do more than one renewal a year to keep up the pace of deterioration of the assets. And so the root causes, track tonnage, specifically in the town centre, because it's the busiest area of the network, loads of people getting on, getting off, getting into East Croydon Station. The trams are heavier, they're going over the tightest curves in the network, not at any great speed, but we've got high cant efficiency curves, and it's eating the life out of our rail as we speak. So we don't have a pace of a renewal program that's going to keep up with the rate of deterioration. So I had to challenge that all the way up to City Hall, essentially. So I did a quick review of all of the exceedances that we have. So what this chart is saying, that everything in the yellow, you should be planning to change within the next 3 to 6 months. Everything in the red, it should have been changed already. We're running on dangerous levels, block the line limits. And what this is saying is, in 2025 and 2026, I'm going to get a series of faults here that's going to shut my track down, essentially. If we get more safety limit exceedances, and that's surpassing anything that's in the maintenance limit, we're going to shut the track down. You can also see the bars are slightly dropping for the maintenance limits faults, anything that's in the yellow. That's because as the asset deteriorates, it gets worsened, and more faults enter the safety limit banding category. And if we want to achieve the goal by 2030 to have a new fleet of trams, this is not the direction that we have to go. The only solution to rail wear in the town centre is to replace it. That's the only solution for us. The broken and damaged rail. So we are also seeing a rise in reported broken and damaged rails over the years, and the number of interventions that we've had to do, stopping the track, closing the service, going in, breaking out the slab to re-rail, putting in temporary speed restrictions. These incidents are rising, these service disruptions are getting greater. So when we put this argument to City Hall, they gladly gave us the funding. Again, this is the forecast, so what this graph is essentially saying from a very big report that was written is that by 2030, 50% of the track, or more than 50% of the track, is going to be in a very poor condition. And eventually, certain parts of the network have to be shut down if it continues at the rate it's continuing. We got some funding from City Hall. We want some more, essentially. And this graph is showing here everything that's in the grey was number of projects that was due to be planned in 2024, and everything is green, following the funding that we received, how much more work we're going to be doing in terms of projects. So this year, there's going to be 7 projects that we're going to be trying to deliver over this year, maximizing our access. So instead of doing 4 renewals, we're now doing 7 in 2026. Instead of doing 2 that was planned, we're now doing 6 the year on, 5, and we've steadily dropped back down to 4 every year of each asset class. So that's a ballasted track, embedded track, road crossings, S&C renewals. So we're pumping a lot of money into getting the track ready by 2030 because we're going to have a new fleet of vehicles. Probably going to be heavier. Additionally, we've got a program with one of the suppliers as well to do reactive works. So we've got them banking rails for us, pre-curbing rails, to intervene at any time if we have any issues where the line has to be closed for a few days. I want to discuss shortly about Shirley Hills and the case for innovation for us. Now, this can deserve a presentation on its own, but I'm going to be very brief and very quick with this one. So essentially, we had Shirley Hills is in southeast London, between Coombe Lane and Gravel Hill. It's a road crossing. It's a nice aerial photo of it. Essentially, it's going across the road. I believe the road's 30 miles an hour, but cars do 60. And we've had a number of incidences here where the keeper rail has broken out. So the picture on your left shows the work that's been carried out to excavate a section of road to get to the keep rail to weld it. It's also bolted together as well. There's tie bars in between the forefoot. This is a very long, hard, difficult task to do. We've got to shut the road, we've got to get cones out, break out the track. This has cost us a lot in maintenance, and we want to move away from this bolted keeper arrangement. The solution is to put grooved rail, which would be great, but fortunately in this location, you see that it doesn't really work out for us. So this is the condition of the road crossing before the renewal. So we've got potholes everywhere, we've got clogged ballast, we've got stuff in the flange way, we've got rubbing of the surface of the flange against the bowl flap there. And these are some of the issues that we wanted to take out. Again, just to remind you, typical layout of the road crossing, where we've got the flat bottom rail, the flat plate bolted with a tie bar connecting those two, and a flat concrete base there. So the idea was to initially use transition rails, but following a report from Manchester in 2006, essentially said that we should steer away from using transition rails within a curve, but also consider where you put the transition rail between track fixities. You're going from ballasted section to a hard fixed, high fixity track section, and where you have that transition rail, it's likely to have rail breaks. So at London Trams, we reviewed it. We agree with the recommendations from RABE, and to put simply, we don't want transition rails in curves. and we definitely don't want them where we have a change in track fixity. This is what the Shirley Hills alignment pretty much looked like. Everything in the yellow is the actual road crossing. Coming off the road crossing is the blue areas, and as you can see, it's curved. To the south of the drawing there, you can see it enters the straight pretty quickly, but to the north of it, it's a continuous curve all the way back to pretty much the tram stop. So what we wanted to do is to ensure that we put this in the right location for us. Here are some of our constraints. We don't want any transition rails in the curve section of the track. We don't want any groove rails present in the ballasted section. The reason why we don't want that is we don't want to extend the renewal, but also putting the grooved rail means I've got to change all the sleepers, dig out the ballast, do a lot of basically a whole track renewal just to put a road cross in. We want something that was anti-skid, low maintenance, and we want to move away from essentially using transition rails. Through optioneering, we had a number of ideas presented to us. One of them was from Poland. I spoke to a team out there about this HK special rail, which is essentially what we've got now with the bulb flat, but it's fixed to the foot and the web of the rail. But all of these options in the green are bolted options. So double S49, which is another option that we can use, or a 4-foot infill panel, something like a strail. This idea, we were almost close to accepting this one, but unfortunately, it would mean another bespoke feature for us, which we're trying to stay clear of as well. So we ended up with the precast concrete modular solution provided by London Section. That allows no transition rails. We get to keep our rails, the anti-slip surface, and protection for our flanges as well. This is what it looks like. This is the factory in Cornwall, went out there. This is one of the slabs that was out. It met the skid resistance. It's got an asset life of more than 40 years. No requirement for transition rails. We don't have to maintain the road surface, so maintenance costs come down tremendously. Flange weight clearance of up to 69 mil. And it's a precast concrete slab solution. What can you not like about that? And it provides a drainage. The design of some of the slabs are not completely straight because it's a curved section. So they're curved in all directions, essentially. This is the design drawing. So it's about 24, 28 slabs over the road crossing. Everything in purple is the drainage that we designed as well to allow the water to flow off, essentially go into these French drains, go into a linear soakaway to the south, and to the north goes into a massive catch pit at the top there. We also did some design around the road crossing for the pedestrians. We've had an island feature here as well, but it's completely transformed the neighborhood and the area, actually giving it a bit more of a prestigious look. This is during construction. Again, I'm a fan of lerps, as you can see. What I don't want is any movement before the crossing round where we have the rail encased in the polymer, because long term, I don't want that to tear away and material and debris get in there. So putting some lerps. This is the transition slab where we have composite sleepers coming off the end of the transition slab and straight into concretes where we're using the 1502s, as I've discussed. Here is setting the slabs down on the screed. Again, it's adverse cant. So as the track comes out of the curve and into the road crossing, it goes adverse because it's a crown of a hill going over the top. So very difficult to design. I wouldn't want to be the designer of this, but thank you. Yeah, we did some ballasting around the ballasted sections, just some reballasting and some ballast gluing. I did have a SharePoint link. All right. You can still see my screen. So I just want to show you what it looks like when we're all done. Yeah, so that's the road, now fully relayed. One of the first cars over the road. All the markings. This is the tying section. Again, we did the glued ballast to prevent people, because lots of people walk. What they do is lazily walk along here, over the pedestrian crossing, and then we'll use the shoulders. So we've got to glue it, unfortunately, with some laps. Here we've got the markings for your swept path. And just, you know, how clean and beautiful. For us, massive difference to what it was before. And we've got video as well. Don't worry about not hearing the sound. I just want you to see this tram go down this. This is the 8% gradient, the hill, a gravel hill, as the tram goes down it comfortably. No issues there. This is just cars going over the road crossing. And then yeah, that was me having a look at Journey Hills. So we're really proud of this project. I really want to come back and probably do another presentation on how we got to where we got to. But it's going to take a day, honestly, to put everything together. Fantastic work. So we want to be innovative at London Trams, and this is what we're aiming to do with all of the engineering departments. I am aware of the time. Yeah. So what's next for London Trams? And the future of trams is positive. So by 2030, hopefully we will have a new fleet of tram vehicles. They're going to be heavier. They're going to have more equipment. They're going to be bigger. There's going to be more of them. The 24 fleet of CR4000s are going. They're coming to the end of its life, hanging on to its last threads. We're going to add another siding at the Rapier Lane depot to accommodate the larger fleet that we're going to now have. So we have already engaged with suppliers on the S&C and the materials around that. And I think the tender's already gone out for the trams itself. We're hoping to get a on-track recording so that can aid us in a permanent way in measurement of geometry, so it's live. Hopefully that still fits in within the budget. We're going to get a new depot control room, which is already 90% built. It's halfway there. And we're going to be continuing to upgrade our infrastructure. I'm going to continue to deliver on this promise to change the strategy of renewals, to do at least 2 of every asset class well past 2030. There is no talk of any extensions at the moment, so I wouldn't indulge in those conversations, but if it comes, we'll be happy to take on board any of those discussions. We're going to get increased passenger numbers. Croydon is developing at a very rapid rate now. Every bit of land in Croydon is becoming commercially viable for flats that are going higher than, they're touching the ceiling. They're looking like Shard. It's looking like a Burj Khalifa over there, honestly. Every other week there's a new building that's going up. The Nestle building is going to be turned into housing project soon. So we are expecting huge numbers passenger footfall on our network. And so to keep up with that, we're going to be updating our renewal and maintenance strategies is what I'm working on at the moment with our partners to produce, CCQs and all of that good stuff on that data. So thank you all for listening. Sorry, I had to cram that all in. Thank you. So I'll open up the floor to you. Please fire away if you have any questions. If you don't, there you go.
All right, I got more of a statement. I'm ashamed to say I've actually torn out 7.5 miles of tram track at one point, but more of a granular question. When you set the top of the rail in the trough before you apply the polymer, do you put shim packs, or how do you get that?
Yes. So there's 2 ways of they doing it. They call it a top-down method or a bottom-up. Essentially, the method that you're talking about is almost like a bottom-up method. So they build from the bottom. They have these packers, which they put underneath the foot of the rail that give it support. It's like a long strip of rubber, and that's how they build the height, essentially.
And then you're free to pour around that.
you're free to pour around that once the polymer is in the right temperature. Now, there's different polymers. The ones that we use, we have to make sure that it's at the right humidity and the right temperature before we pour it. And they try not to get bubbles and stuff that's inside the polymer. So that's another complex task as it is. They're going to heat it up, get it to the right humidity, get a tent over it. It can't rain. So in East Croydon, when we renewed it, it rained slightly and that messed up a little bit of the job. And of course, when you're in an area where you're on a gradient, because it's a liquid, it's going to settle. And so we've got to do that in stages going up, as you would with concrete.
And then how do you pull the gauge then from the top?
Yeah. So as you normally would in ballasted track, you get a track gauge, you set the gauge. Once the rail is set in its position, it's not going to move.
Cool.
Essentially. Yeah.
Thanks for that.
That's all right. Yeah.
Yeah, I'm just going to say on the interlacing,
Yes.
it saves you 2 sets of switches.
Yes, it does.
Yeah, so that's the advantage that, I mean, given the way your signalling works, which is by occupancy with the loops, it's easy for that, but you're not having to prove 2 sets of switches.
No, you're right.
So you get really good on that. One thing that might bring home to people the issues of the openness of the system. About 12 years ago now, Croydon Advertiser regularly asked about accident figures. And one year, somebody actually gave them every accident on the system for a particular year. And I plotted it out and looked at whether it was on the shared running section, the segregated section, or the ballasted section. And it actually is a very good inversely proportionate that if you've got 80% of your track is ballasted, you actually got 80% of the accidents on the shared section. So there was a really good inverse correlation, which just brings home to you where the accidents are. It's all on the shared section. And I think that's something I've used more widely just to emphasize to people, this is what you're in for a tramway.
Yeah.
You're going to get lots of accidents on the section, and you shouldn't be looking at it as a railway. You look at it as the highway environment, because that's where your accidents are. Don't try to look at it as a railway from an accident point of view.
Absolutely. Yeah. We've had incidences where we've got cars being chased by police.
Yeah.
They went into the ballasted section. That happens quite a lot. And so, honestly, some of the reports we've seen are scary. But you are right. Inversely, there are a lot of issues in the outset of accidents.
So effectively, get highway code in the town centre.
Yeah,
that's right. Yeah.
A tram is a road vehicle when it's on the road. Yeah, it is nominally subject to construction and use, although the only part of construction use it's subject to is the first part that says it's a vehicle. But it's very much subject to the Road Traffic Act and Road Traffic Regulation Act. So it's a road vehicle.
It's got indicators, brake lights, reverse lights, headlights.
Good clap it.
You mentioned flangeways, very, very narrow flangeways. Why are they so small?
I've asked this question before, but
It's to protect cyclists.
well,
Oh, I see. Right.
everyone's got a different theory on this.
That's the one I've always understood. It protects cyclists. If
Everyone's
it's
got
too wide, particularly if you're running on the street, you don't want cyclist tyres getting down.
No, you don't. But also, it's also evident within the S&C. So I get it if it's in the road crossing that you don't want cyclists, but in the ballasted section where we've got S&C, the flangeway is equally tight. And their reasoning for this is because tram wheels have narrow flanges, and it's likely that they can go down the unintended path. So they want to bring it over closely away from the wrong side of the nose as much as possible. That's why they have narrow flangeways. So, but I've heard many different reasons, and I tend to
Creates a circle though, because you use wheels with narrower flanges. Therefore, you have to pull your flangeways in. Therefore, you can't use a standard wheel because you've now got infrastructure that means you can't change, and therefore you perpetuate the issues, really, don't you? Find yourself a bit stuck.
All your standards, are they bespoke, or do you you borrow TfL standards, or and how big's your standard library? Is it is it a big?
It's not. It's
You
not.
that's a right lot of standards down there, or
It's not. It's not a big standard
No,
library.
no.
I do borrow from other networks. If I'm honest with you, they've got the teams, the resources, but we do have our own document specific stuff where I can. I've offshore many times. This, that, welding, but I steal from other networks. The flexibility with Tram is we can do that as long as the head of engineering okays it. There's engineering rationale. I'd write a technical notice to review. They're happy to change standards where and when, but that's the whole point of tramways, isn't it?
you still got a lot of network rail tracking, the Wimbledon branch and
Yes.
the original track form, or
Yes, the same alignments from 200 years ago. To be honest,
the sleepers, and not from 200 years ago, but
no. The oldest section of track is between Woodside and Arena. It's a straight section of track, and it's got 1950s rail in there.
is that Croydon? That's Croydon end, is it?
No, that's in the
Addiscombe.
Addiscombe. Yeah, that's right. Yeah, Addiscombe.
Pan 8 base plates with lots of
That's
spikes.
There's spikes.
Good
Yeah.
job.
But also in the depot,
Yeah.
you've got old DR rail too. We've got 1950s cargo rail. We had some the other day with some piping in it.
Right. Yeah.
Some vertical, longitudinal spit in it. So
That was a new depot, wasn't it? Or
no, I think that was already there. Is that
it was never original?
Never
Original
Okay.
BR yard? No, I don't think so.
No, it's completely new when the tramway was built in the late 90s.
Right.
But one of the things they did was they got rid of all the bullhead track on both ends. So there was no bullhead track when it opened. But they sort of collected bits of rail from all over the place. The places where they had to put new flat bottom in because the bullhead was needed for loop purposes and whatever. But there's some interesting track out there on the plain line.
It's had some interesting bits with corrosion as well. Hasn't
Yeah,
it?
yeah, yeah. Corrosion. So in Sandylands Tunnel,
Railfoot.
corrosion, yeah. Sandylands Tunnel, I just re-railed it a couple of weeks ago, but we've had a constant stream. It's a river in there, essentially. So rail foot corrosion is terrible.
Did you go for any coating on it this time? Or?
No, we didn't. I wanted to, but funds, we are where we are.
And get the job done.
Yeah. No, I did use the Sherrodized componentry for the keys and stuff like that. But yeah, the coated rails have a very long lead time.
You almost get it up on pedestals. Go for high.
No, well, I guess you could. Again, it's funding, isn't it? So
Yeah.
if you want to do all of that Delco stuff, I mean, it's a ballasted tunnel, ballasted track.
Yeah. Then you're going to a slab track and then lifting
Yeah.
rail out of it. Too much money.
Yeah, too much money. It's an old tunnel, though. It's 200-year-old tunnel.
The other problem is it's got a walkway down it.
Yeah, it's got a walkway in it. Yeah. So if passengers are stranded, they can.
It's not an infrastructure.
All your wear problems is it head wear and flange contact? Is it? It's not.
All
Or
of
is it a
my
mixture
wear-
of side wear and head wear? Or
It is a mixture of everything because of the curves. Sideways pretty aggressive. I would say it's a mixture. I can't say it's one specific thing or the other, to be honest with you. It depends on the environment and where it is. Yeah, certainly a problem for us because we're not renewing at the pace that we should be doing. But hopefully with this additional funding, we can get some of the scary spots out of the way. Like you were saying, John, at the crossover at Sandylands has had speed in it for years now. And so we're looking to do that in February next year. But we're going to renew the entire slab. So the original plan was just to do the crossover, but the whole slab's going to get done. The drainage in there is so poor. And we just have to live with the asset until then. Yeah, definitely. So I might put that same precast concrete slab in there, providing that we get a supplier that can build the S&C for that slab. So, we're still having conversations on that.
Spring points, are they all detected?
No.
So,
Well, locally they are.
Yeah.
Yeah, there's some kind of local light to show the drivers that
Yes.
they're in the right position, isn't there?
But there's nothing to feed back.
Yeah, I think if you mentioned these damping devices particularly, that's a thing that could fail, and therefore your switchblade might not go all the way back. So, but there's localized, safe proceed lights.
I mean, that's very rare. It's the way they're like Schweier gondola rollers, basically. That's all it is.
Okay.
So they don't. They just prevent the rails from slamming into the stock hard. It just dampens it slightly. And it allows for that free movement. So we put them at hand points as well. So where operator swings over, so it should be a lot easier to do. Trying to do it without.
Thank you.
Sorry, just on the machine crossings, steel crossings, yeah?
Yeah.
What's your experience? So do you get much cracking or
Nothing.
or any defects at all?
No, we don't. If we do, someone's been on the track with a machine.
Yeah, it's damaged. It's not.
Damaged.
Yeah, it's not inherent cracking or
No.
defects. No.
It's a solid
Steel
block. Yeah, steel block.
And it's
that they
machined,
out.
and that's VAE.
Yeah, VAE. Yeah.
Cheaper than manganese?
Cheaper than I don't know what the cost of it is.
Oh, okay.
Honestly. I don't get to look at that as an engineer. Not allowed. But it's pretty interesting. It starts off that size of this desk. 2 meters long, 0.5 meter wide, and they can machine out of it, and it's like a shiny.
Yeah, they got it in Manchester, I think.
Yeah. It weighs a ton, honestly.
Bushlow been trying to push it onto us, but it sounds like a good.
It's well repairable too.
One thing to remember is that you can't really use manganese rail
No,
because of the track brakes.
Yeah.
You've got track brakes.
right.
And when there was a short piece of manganese rail near West Croydon tram stop, there was actually signs up to tell the drivers, be careful because you can't rely on the track brakes.
Okay, guys. Right. Thank you very much, Omar.
Thank you for having me. Thank you for listening and turning up.
It was a very interesting conversation, which prompted a number of questions.
Yeah.
It is a novel network, and I think you actually articulated that very well. And thank you very much. I think everybody enjoyed it. Okay. Just in terms of
Thank you very much. Bye.
Thank you.
Thank you.
Thank you. Thank you very much.
Further to the future, the next meeting is on the 4th of June. It'll be a presentation of the Piccadilly line upgrade, and we'll also take the opportunity to have the annual AGM. And also the seminar for November is now open for bookings. It's working together to make track renewals affordable. It's in Birmingham. If you want any further information, I suggest you contact the PWI website. Thank you all very much, and a show of hands for Omar, please.
Wow, thank you. Yeah.
All of them was actually very keen to get hold of the list of people who could to come in here. But you couldn't make a booking unless you're a PWI member.
Oh, yes.
I've come to this because we're just doing a project with Edinburgh. Spin out.
Thank you.
Yeah.
I'll bear that in mind.
I'm a salesman now. I gotta give him a card.
It's very much. Click here to make a reservation.